Hello friends, good morning. Welcome back to our channel ALP Talks. This is your Lakshmipati. Today we have Mr. Jatin with us for our web interview. Today's discussion is a brief discussion on measurements and calibrating instruments and metering instruments. So please watch it. This video will be in two parts, part 1 and part 2. In this video we are going to discuss different measuring instruments, ammeter, voltmeter, CT, PT, watt meter and gas meter and other meters and NABL laboratory and maintenance of measuring instruments. So these are some minimum info. So if you go through this video, you will get some good information. So and other parts like current injection, testing of CT from primary side, secondary side, testing at sites. What is the charges for testing? So some good stuff we are going to discuss. So if you are interested, you can watch a full video. Otherwise, I mentioned in description some timestamps about each topic. You can go to that particular topic and you can watch it. So keep watching, guys.
Morning, sir.
Yeah, good morning. Welcome back to our channel, ALP Talks. How are
Yes,
you?
sir. I'm fine, sir.
Good. Nice to talk to you. Yeah, first of all, thanks for accepting this meeting. I conveyed to you yesterday only. You accepted it. Thank you.
Yes, sir.
Yeah, there are so many people watching our YouTube channel ALP Talks where I'm posting all electrical related stuff.
Yes,
So
sir.
thank you, welcome again. Yeah, how are you? How things going on there, man?
Fine, sir. I'm fine.
Good. Okay. Yeah. So we will directly jump into our discussion. So
Yes, sir.
yeah, can you tell a few words about you? I mean, who you are, what is your educational background, what is your professional background, so that it's good.
Sir, my name is Jatin Saini,
Can you
and I'm
speak a
from
little bit
Jodhpur,
louder?
Rajasthan.
Yeah.
Hello. Sir,
Yeah.
my name is Jatin Saini.
Yeah.
I am
Proceed.
from Jodhpur, Rajasthan. I graduated from Government Engineering College, Jhalawar,
Okay.
Rajasthan Technical University. And my professional background is I'm engineer at Calibration engineer at Yadav Measurement Private Limited from since 3 years, last three
Okay.
years. And now I'm going to do something else because in calibration I spent 3 years. Now I want to go in testing department so that I can learn more about testing of meters, testing and mm,
Yeah.
other testing on
Yes.
meters and other references. Yes, sir.
Okay. Good to hear. Yeah. So, how you entered into this? Is this your first company?
Yes, sir, this is my first company.
Okay. Is this through college or somehow other way you have entered into it?
No, some other how I updated my resume on company HR, and then they called me, and then I get selected in this company.
Okay. Good.
Mm.
Yeah. So in today's world, measuring instruments plays a major role for all the
Yes,
parameters.
sir.
Yeah, it may be light or it may be current, voltage or watt meters, energy meters or flow meters, frequency meters. Yeah, we have so many meters. I think
Yes,
you
sir.
are
So
better
many
aware
meters.
of than me. So can you explain
Mm.
something about what things we have in measuring means so many stuff we have general way what meters we have outside world, so where they are using, can you explain a little bit?
Sir, we are using meters in our, mm, I think, in all types of field. First of
Mm-hmm.
all, in our house,
Yeah.
in grids, power grids, in utilization grids, transmission grids,
Mm-hmm.
and we have also reference meters. Reference meter from all the meters. Uh, can I speak in Hindi little bit?
I think English is good.
Okay, no problem.
Yeah.
We have reference meters. Reference meter is the main meter from which
Mm-hmm.
all the meters are concluded.
Okay.
Okay, so we have energy meter that we will use in our house. Okay, that is what kilowatt meter and
Mm-hmm.
watt hour meters. And in
Mm-hmm.
our grid and substation, we use megawatt meters and gigawatt meters. So
Oh.
what is difference between these two meters? Because from the generation station, generating plant, the power, suppose the power is generated 1000 gigawatt or 1000 uh, uh, let's take it 500 megawatt.
Okay.
500 megawatt is power generating from generating plant.
Mm-hmm.
So it should be transmitted to any area, or then secondary substation,
Yes, yes, yes.
transmission station, then distribution station, then it comes to our house.
Yes.
Okay, so the basic thing in this, that the power which is generated 500 megawatt. Okay, the generating plant costs 500 megawatt to generate it. Suppose it cost 2 crore rupees.
Mm-hmm.
So how can he get that 2 crore rupees back?
Yeah.
That's the main process, because in this we have transmission losses, we have distribution losses, and we have other types of theft cases also in our household and in our village
Yeah.
types of.
Yes, yes,
So
yes.
that 500 megawatt is purely distributed to our house, to our companies, okay, to industrial areas. So in that we have to measure these units. We
Yes.
have to measure that 500 megawatt is going where else, and how much is it is generated, and how are the losses, what are the losses that cause. So in generating plant, they generate 500 megawatt, but the total calculation, we have meters on grid, we have meters on household, we have industrial meters also. On calculating all the time, we get only 450 megawatt. So what
Yeah.
about 50 megawatt?
Yes,
So
yes.
this is so there is a necessary of measuring this power. So we use different types of meters. Okay. In gas we use gas meters. In this voltage, in this power unit, we use electromagnetic meters, which is called CTBT operated meters,
Yeah.
in which CTBT operated meters are are of various different classes, just like point 2 classes, point 2s class, point 5 class, point 5s class. So these are a defined class of different measuring meters.
Okay.
Okay, so basically these meters are we can say point 2 class means, it is of point 2 accuracy,
Ah.
which is called its minimum error, in voltage and current and in power circuit.
Okay.
Because yes, just like we can take point 2s meters. Why it is called point 2s meters? Because it is CTPT operated meters. The CT current transformer and potential transformer used in that meters
Okay.
is of point 2 and
Accuracy.
of point 5 class,
Mm-hmm.
point 2 class.
Okay.
And that CT is classified CT according to BI, Bureau of Indian Standards 16227. This
Okay.
is a standard 16227. So from that we the manufacturing make in standard CT. From that CT, all other CT are being manufactured, and that is what called our main CT or a reference CT.
Okay.
So we use that in our meters, and we also test that meter on that accuracy class. That means if it supply 240 volt, then that meter will read 239.999 or 998 or
Wow.
240.001 or 002.
That
And
much
that's we
accuracy.
call, yes, that's mean accuracy. That's mean accuracy because we define accuracy in terms of resolution. Point 2s means it's of accuracy, or it's of error of plus minus 0.2%.
Oh, okay.
Eh, mm. We supply 240 volt, 240 volt supply, but how we know that 240 is coming or not? Different types of meters are there. Are good manufacturing meters, just like secure meters,
Mm-hmm.
or LNT meters, and LNG meters also there. Siemens meter also there. So when you compare different types of meter, then they will read 239.9. They give resolution from which we can define that the 240 volt is coming is accurate or not. There are some local companies also with manufacturing meter or third class meter. They read 240 to 242 or 241. They don't give any resolution, so we can't say that this meter is accurate meters.
Okay.
So we use these meters in different types of fields, just like our industrial purposes, because industrial purposes they use the load of 10 megawatt, 50 megawatt,
Yeah.
they get 100 megawatt. Just like big industries, Reliance Industries, or some there is manufacturing plant, they use different types of uh, more loads, because they are using heavy machines, so they require more loads. So in industry, in industry purpose, we use CTPT operated meters, because in that the billing is approx 10 to 12 lakhs per month or per
Yeah,
2 month.
billing is high,
That is
those amount.
yes, yes. So these are the energy meters which we use in our electrical purposes. Now there are other meters just like gas meter. Gas meter that we most of the gas meter I think we used in Delhi because IGL is Industrial Gas Limited. So they are using gas meter. In that also gas process is same. How much we are giving and how much they are
Consuming.
uh, consuming and what are the cost we are taking, because if we supply if I giving 100 rupees, then how much I can get 100 get, or I can get 90 only, or I can get 95 only. So that is the main process, and that is the main thing that we're using energy meters.
Okay. Yeah. Nice, Jatin. You explained clearly all the general things, general meters,
Yes,
how what we are there in the industry. Yeah.
yes sir.
Yes, yes, yes. Yeah, I seen your profile and all, so I have some doubts in my mind. Yeah, it may not be my doubts, it may be doubts of the other audience also who are watching our videos, general doubts. So I noted something, so we will discuss those things one by one, and at the end we can discuss some general also. Yeah.
Yes sir.
So calibration means what you will do generally. I mean, can you explain something? What?
So calibration is the process of measurement,
Mm-hmm.
true measurement, in which we define the its any instrument accuracy class. We can calibrate it from its accuracy class, and we will give or resulted we will give error, just like we can take multimeter.
Mm-hmm.
Okay,
Mm-hmm.
how do we calibrate a multimeter? Our multimeter do the measurement of voltage and current, frequency, AC/DC frequency, AC/DC voltage, AC/DC current, frequency. So these are the things that multimeter can measure. So how can we check that the multimeter is measuring 1 ampere current is accurate or not, 10 ampere current is accurate or not? Okay,
Mm-hmm.
the voltage coming through the line is 240 volt is accurate or not? Because in multimeter there is a resolution of 2 decimal or 3 decimal. Okay,
Okay.
so suppose from our uh, in our switchboards I check the supply, and it is coming 236 volt.
Mm-hmm.
Okay, but 236 volt is the multimeter is reading. Okay, but the supply is going to 40 volt. Okay, so now these are this is the measurement of multimeter, that multimeter is reading 236 volt. Okay, so now is this 236 volt is correct or not? No, it is not correct, because we have to measure only 240 volts. That is only correct. So for measurement of multimeter, we use different standards, different standard instrument, just like our 8.5 multimeter, 6.5 multimeter. These are reference multimeters. Okay, they are of higher accuracy and they are of standard measurements.
Okay.
6.5 multimeters are giving resolution of 6 decimals. So
Okay.
that is why it is called 6.5 multimeter,
Mm-hmm.
because it gives after point it gives 6 decimal resolution. And 8.5 multimeter it also give after point it give 8 decimal, 8 decimal resolution. So
Okay.
when we measure the multimeter by applying to 240 volt in comparison to 6.5 multimeter,
Mm-hmm.
in comparison to 6.5 multimeter, and compare our normal multimeter, which is giving resolution of up point just like 239 point 236 point, you can take 236.98. Okay, or 236.72. So our reference multimeter, which is 6.5 multimeter, so it will give resolution of 239.99996. So by comparing these two measurements, we provide an error, because these our measured value is 236.7. Okay, but our true value, which is giving our reference meter, which is giving true value, is 239.9999.
Mm.
So from the error formula we can calculate it its error, that is measured value minus true value upon true value multiplied by 100. So an error going to be calculated, and we will report that error in our certificates also. Okay, so this is the calibration that this multimeter having an error of plus minus 0.002. It is calibrated that this multimeter having an error of plus minus 0.002. So if you are considering any voltage or any current measurement or any frequency measurement, so you should take that error in mind, that it is having an error of plus minus 0.02 or whatever it is calculated.
Yeah. So generally, say for example, you are saying say you reported 0.2% error. So what the
Yes,
customers
sir.
will do? I mean, they purchase it for zero point 0.1 error, for example, due to,
Yes, sir.
I mean, due to some time of usage. Why those
Hmm.
results goes wrong? Why, for example, there is some rule that every year you have to calibrate something like that, right? Some
Yes, sir.
time period will be there. Why
Yes, sir.
why the time period? For example, today you calibrated it. Next year, same day you may be going to calibrate it again. Why
Hmm.
during this 1 year it will goes uncalibrated? I mean, can you explain something?
Sir, because there is in instrument, all instruments are not 100% accurate, and all instruments are not 100% measuring correctly. Okay, there are some, you can say, in 1 year it can shift, just like I can say that it can drift. Okay, its measurement can drift to some points, just like intakes of whenever we take manual of any instrument, so there is a drift calculation is given. Okay, that per year the instrument is drifted from 0.002 class of accuracy. That is every manufacturer will give this. That drift is what the drift means. If it is reading 240 volts, so per year it's 240 volt, it will read 239.998. So that's 0.002 per year. It's depreciation, or its error got shift with the help of usage. मतलब how many times you use that instrument, or in what condition you use that, you in if you are using at site, transport, in transport the instruments are also get affected, or because there is on calibration of instrument we required some standard to follow from our NABL standard. We should follow some NABL standard on calibration of instrument. From that, in this condition, or in this state, that type of instrument you can calibration, you can do calibration for that instrument. So
Okay.
that's why we require to do calibration yearly, or within 2 years, or within 5 years, to
Okay.
check that instrument had shifted, how much the instrument had shifted its accuracy classes. That's why we do calibration in yearly, or 2 year, or 3 year, or 5 year.
Okay. For example, today we purchased 1 meter. Say every year you are doing calibration. Say after
Yes, sir.
5 years, if
Hmm.
is there any lifespan like that? Generally, for any device, lifespan will
Yes,
be
sir.
there. How you will
Yes,
divide
sir.
the lifespan of these measuring instruments? Yeah, it is dead. We don't use. How you will decide? Like,
Suppose manufacturer is giving 5 year warranty on 1 meter. Only energy meter. We purchase an energy meter, and it will give the 5 year warranty in that meter. 5 year warranty means within 5 years it's having an accuracy class of 0.2s or 0.5s. Suppose I purchase the 0.5 accuracy class, 0.5 is accuracy class meter.
mhm.
So up to 5 years, its accuracy class is within the limit, within 0.5. Okay, not uh, I think you can say that within 5 years it will be in its class only, just like 0.2s or 0.5s. Okay, but after 5 years the manufacturer will not give you any uh, warranty or any promises that it will shift to 0.6 or out of the limit, or it can remain in the limit. See, so that's why we have in energy meters uh, in industrial purposes where higher loads are used. Suppose in a mobile manufacturing company, it is using 10 mm, 150 kilowatt or 250 kilowatt its load. Okay, on when the industry is on full power, and then it will use 200 kilowatt. Okay, so now there is a I purchased the meter a 0.5 accuracy class, and I connected in the industry. Okay, so I'm using 200 kilowatt per month. Suppose after 5 years the meter has shifted to 0.6. It is limit its accuracy limit is 0.5. It's pointed to point shift. Now in this case, when we calibrated, I calibrate the meter, so its accuracy class is 1. It shifted 0.5 to 0.6. Its energy accuracy class, its error has came to 1%. 1% means it will go to minus also or plus also.
Plus also.
If it go minus 1%, then it will be benefit for utility. How it benefit from utility? Because utility is charging for 200 kilowatt. And 1% of 200 kilowatt is I think
2 kilowatt.
2 kilowatt, which is decreasing from its consumption load. It is using 200 kilowatt, but now it is only using 198 or 195 kilowatt. But he is paying for 200 and 200 kilowatt.
Yes.
Okay, he is paying more.
Yeah.
Utility is in profit, but it is plus minus plus 1%. Then it is you can say utility having a loss of 1% power. 1% power. Just like he is using 200 kilowatt, but the meter has an error of 1%. So the utility is charging for 200 kilowatt, but it is using 210 or 220 kilowatt. So that is the main difference.
Yeah.
So in terms of, we can say the meter is calibrated for the cost purpose, for the utility cost purpose and for the customer cost purpose. If meter is going out of the limit, then who will pay that money? Who will pay? Suppose I am the customer, I'm taking 200 kilowatt load, but the utility wants me to pay 250 kilowatt load. Then how would I pay to you? Why I should pay that 220 kilowatt extra 20 kilowatt you? That is your meter. You have to change it. You have to calibrate it. So utility, every year utility calibrated its meter or voltmeter, wattmeter, energy meter, or frequency meter. So it's the responsibility of utility, and it's responsibility of customer also, because sometimes customer says that I'm running only this much load and the amount of bill is very big. So how this is possible? So customer contacts the third party company, which is just like our company, Yadav Measurement. So customer contact us to check our meter, to check our current transformer, to check our potential transformer, because this is the metering unit. Current transformer, potential transformer is connected to the energy meter. So this is called the metering unit. This is called the metering system. So where we can calculate the meter error, CTPT error, and we can say the customer that your system is within limit. Okay, whatever you are getting the amount you have to pay.
For example, if you say you are paying more, you have to ask with your company. Then that board, electricity board, will agree your result.
Yes, electricity board we agree, because our company is NABL accredited lab, National Accreditation Board of Measurement Laboratory.
Yeah.
So we have NABL accreditation.
Okay, so they will approve. They will agree
Yes,
your
so
results
that
and they will consider those results.
yes,
Okay.
yes, because government also approaches us for calibration only, because government know that customer will never believe in ourselves. Government know that the customer never believe that he is getting more money. So government also approaches that you have to check that meter, you have to do that CTPT. Government gives us tender of different types of sites that you have to calibrate this meter, 500 meters, 1000 meters. The government also approaches us. so
Okay.
that our yes sir.
Mm-hmm. So all the, for example, whatever boards we have, you are going to the all the industrial customer and calibrating all the meters, right?
Yes sir, all the industrial customers all over India.
Okay, okay, yeah. So we might have so many devices, a voltmeter, like ammeter, so something like that.
Yes sir,
So,
we have reference standards according to NABL. We
mm,
have reference standard of 10 times more accurate than the measuring instrument. Suppose the energy meter is of 0.5 class.
mm-hmm.
So we have our reference meter of 0.05 class,
Okay, okay. So better
10 times
accuracy.
better than that meter. Yes, sir. It
Yeah.
is compulsory and it is requirement of NABL that whenever you calibrate any instrument, so you should have accuracy of better than 10 times better than that instrument. Then
Oh,
only you will calibrate that instrument.
yeah, yeah, yeah. That's true. That's true.
So that you should get the best accuracy, you should get best error. Okay, so this is
So the calibrating equipment, like standard equipment, should be far better, right?
yes, sir, far better, 10 times better, or sometimes customer can use the 20 times better or 50 times better. It's
Yeah,
according to customer, just like Schneider Electricals, then and ABB panel designing and Siemens. So they want that we want the standard equipment should be 50%, 50 times more better than our instruments.
yeah. So that it is more good result
Yes,
it
sir.
will give.
Yes, sir. It will give good result and it will beneficial for them also.
Yeah, 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 that's true. Thank you. Thanks for watching. Stay connected. Subscribe to our channel. Please continue watching for a part 2 of this web interview.